Time to upgrade. Why would I take apart a perfectly good and well-running 911? To me, it's to make it better, and this car is always evolving. And I think the top 3 reasons for going with these PMO individual throttle bodies are, number 1, performance. You're gonna get more airflow, it's more torque, more power, and much better throttle response with these individual throttles right on top of the heads. It's gonna be amazing performance. The second reason I chose these PMO ITBs is because they really do look like vintage carbs. This is a backdated 911 long hood in the 69 to 73 era. So this does look like a carburetor. In fact, it shares some of the throttle shafts and throttle blades. But the only difference is it has these electronic fuel injectors, and they take the place of everything internal to the carburetor. No more floats, no more needles and seats, no more mixture screws, no more emulsion tubes, no more pump circuits, idle circuits. Any of that stuff has been eliminated. It's all been replaced with these little injectors. And they're on the side, so it really does, to me, give it a very vintage look. The third big reason is to improve the sound of the engine. So much about owning a vintage car is about that exhaust sound, and flat sixes make an amazing sound, especially through the intake if you have something like this. So this is going to give you that throaty intake sound when you step on the gas, and it's just going to be like a whoosh of power. So it does change the driving experience even just by sound. Those are the top 3, but there's even more than that. These have a pretty dramatic weight savings compared to the original EFI from the 1989 engine. That's 30 pounds. These guys with the intake manifold are just under 8 pounds. So that's a 14-pound reduction in just the intake system. The air cleaner isn't on the other one, but they're almost roughly the same between the dual air cleaners and the single stock plastic one. The wire harness on this build will be a lot lighter than the stock wire harness. So I'm calling it about a 15-pound savings, just going with a more modern system. And just like that, we have the original EFI system from 1989 removed as one piece, mostly. And when you upgrade to a standalone ECU like we're doing on this engine, it gives you full ability to make upgrades like exhaust, camshaft, piston, compression ratio, fuel pressure. Any of that stuff can then be adjusted in the standalone software to control the new fuel map, the ignition map, all the acceleration, deceleration parameters. You can control torque. There's all kinds of things you can do with the standalone EFI that you just can't do with the stock Motronic system. So now with ITBs, the sky's the limit in terms of how wild you can do cam selection and piston selection for these Carrera engines. The stock Carrera heads are actually pretty good. What they really want is a big cam, and now we can do it. Ah, ta-da, here they are. These are the 46mm butterflies, and that's a good size for a 3.2 or larger engine. They also make them in 50 and 40, I believe. 46 is perfect for the Carrera engine. It is individual fuel injection with a common fuel rail, so these will be sequentially fired with the computer, and it has a solid throttle shaft, just like their carburetors do. All butterflies are on the same common shaft. So they're manufactured to a very high precision, so the need to adjust individual throttle blades is really not an issue. Let me show you what I mean. This is the smallest feeler gauge I have. It's 1.5 thousandths. And so if I turn these upside down and I open the throttle and just let it kind of grab onto the gauge, just letting it grab on there, and I can feel the drag. It's a very light drag there. That's about 1.5 thousandths. It's a very light drag. And I go to the middle, I get roughly the same amount of drag, which means the distance that air can sneak through is roughly the same. The other test is if I hold these up to the light and look through them, I can see the same amount of light peeking through each of the throttle blades. Each of these will draw, I think, the same amount of air. We can double check that with the synchrometer once the engine's running. So if this for some reason is flowing less air, we can sneak a little bit more air through this bypass screw. It would be just a very, very minor adjustment. Generally you want these closed, but it does have the ability to adjust because you don't adjust it on the shaft, you adjust it on the bypass. Personally, I think this is a benefit because there's less moving parts on this design than some of the other individual throttle bodies that have individually adjustable butterflies. You know, Porsche tried that on the 912, the 4-cylinder. They have individual throttle shafts, and most people today revert back to solid shafts. There's companies that convert the split shaft carburetors into solid shafts because over time, tens of thousands of miles, you don't want this getting out of adjustment. And as long as you set your linkage correctly and you set your pedal stop correctly, you're not twisting on the butterflies, they should never go out of spec. So to me, that's a win. The shafts ride on ball bearings and they have these great springs on each side. So the same amount of torque is applied to this end as there is on this end. So that creates a more stable shaft. So the shaft itself is not twisting. It's got the same amount of torque on each side. The other nice thing is they've chosen some very nice flush screws for the throttle shaft. And if you look at the other end, they are trimmed so that they don't protrude through. So the cross-sectional area here for airflow when it's wide open throttle is actually quite good. These are 46 millimeters. The port on the head is 41 millimeters. So the cross-sectional area here, even though it's got the shaft, is still bigger than the port area. So this is not a flow restriction at all. This is just a means to control the engine for cruising. You can do part throttle, half throttle, whatever it is, you're controlling how much torque the engine provides by how open these things are. The other nice thing about PMO is they're made in the USA. They're actually made like 20 minutes from here. I've been to their factory, I've been to their warehouse. They do all their machining. Everything is done in-house, assembly, quality. It's actually top-notch. The other thing PMO provides are these vacuum ports, and it's vacuum to each of the individual cylinders. And these do two things. One, it helps you control the idle because the throttle blades will be fixed. It's closed, it's in idle position. But when it's cold, we can sneak extra air underneath the throttle plates into the intake manifold so that we can get a little bit higher idle when the engine's cold. There's something called the idle control valve that basically controls how much air can leak into these. The other reason for these is this is one of the signals to determine how much load the engine's under. So manifold absolute pressure is one of the methods we're going to use to control the engine under various loads. These are the Bosch 968 green injectors. They will flow plenty of fuel. They also have a very modern spray pattern and easy to control idle. And they are mounted on an angle pointed right into the heads. There's a little half moon here at the junction between the throttle body and the manifold, and that's something that could be improved. This is what the manifolds look like on the engine, and you can see that the gasket and the manifold itself is purely round. So see that little half moon there is blocked when you put the gasket on it. So the spray pattern coming out of the injector is a cone, or 2 cones, I think. Part of that fuel spray is going to run right into the gasket. So if you're super meticulous and nerdy like me, it might make sense to port match the gasket and actually the manifold so that that spray pattern is not interrupted by a step. So if I take one of the injectors out and you peek down that hole, you can see that green gasket. So there's plenty of material here where that half moon would just, ever so slightly have a little indent in there. So that injector pattern can flow right into the valve. So inside there is the valve. In an ideal world, the injector squirts right onto the head or the back of the valve. That's the hottest part of the intake system. That'll vaporize the fuel even more. It's going to be like a fine mist as it comes out of the injector, but it's going to hit that valve and it's going to vaporize even more. And this is all injected prior to the valve opening. So when the valve does open, that hot, steamy mixture will go straight into the engine piston area and then get compressed and then explode it. So that's going to give you more power if you can atomize that fuel correctly. If it hits a little step here, it's basically just going to drip down. Ultimately, it's going to get into the cylinder, but you want to avoid drips. You want to keep it very atomized. These fittings were purchased by me. This is the return fitting. It's a banjo. A little more restrictive on the return, but the supply side just goes straight into the fuel rail, and these are AN6 fittings. So we have no restrictions on the intake. We have some restrictions on the return, but that's okay because at max fuel demand, most of the fuel is going into the injectors, not into the return. And it does have a filter element and have a complete rain hat and filtered air with basically 4 nuts hold that down. And then we can vent the oil tank into this part of the air cleaner here, where those fumes will be sucked into the intake so we don't create a mess in the engine bay. We could also, we could also get rid of this and just use a catch can. I haven't decided what to do on that yet, but this is how it comes from the factory. So that's it for the introduction on these throttle bodies. I think they're awesome. They're actually cheaper than carburetors. However, the total system is not cheaper. You have to have a bunch of sensors. Let me go through all these sensors that you need to run fuel injection, especially sequential fuel injection with sequential spark timing and coil on plug. There's a lot more to it than just the throttle body. So let's get into that. One of the important things to install is this guy. I actually have 2 of them. These are the NOx sensors, and this is very important when doing a standalone ECU, that you're able to determine if the engine is detonating or knocking. So the 993 engine uses a bridge that's located just about here, and it measures any of the cylinders that might knock. It transmits a signal down the bridge into the sensor, and they use one on both the 123 bank and the 456 bank. So I just need to drill 3 M6 holes here into the heads to mount this bridge. The next important sensor to install is this Hall effect sensor for the cam. This is going to tell the ECU where the cam is in the compression cycle. It goes on the back of the cam tower. This guy slides in here, and then there'll be a pickup protruding out of the cam, so every time the cam goes around, it'll create a signal here on these 3 pins. Here's the camshaft. That's that cover that we need to remove, and it's a lot easier to remove when the engine's apart, but I'll come up with a way to get that pulled off. So because this engine's going to use these individual coil-on plugs, we're going to have 6 different ignition coils right on top of the spark plugs. That eliminates the need for the stock distributor. So the stock distributor is gone, no more distributor wires, none of that's going to be here. So this is a plug that just blocks the hole there for that distributor. And because there's no distributor, the engine does not know when to fire the number one coil. That's this one here. That's why the cam sensor is important. So we're going to put it up to top dead center on cylinder number 1, and then we're gonna back it up like 120 degrees, and that will give the sensor enough time to communicate with the ECU, then to fire cylinder number 1 just at the right time. This throttle body on the engine has another sensor on it. It's attached to the shaft. This is a throttle position sensor, and the computer needs this to calculate how much fuel and ignition to add based on the throttle angle or the engine load. This is the plenum that combines all 6 of those ports into one, and that allows us to measure the manifold airflow pressure. This is the sensor here that measures the manifold absolute pressure. This is a GM part. This is an intake air temperature sensor, and I did drill a hole here in this base plate to allow for that to attach. It's basically just a little kind of 2-pin sensor, measures the ambient air temperature, so the computer can know, again, how to adjust the fuel density based on how much the air density changes. So that's a calibration thing for that. So this is the one that measures the crank position. This is also from Clewett, and it's basically a little toothed wheel that goes on the back of the pulley. It's a brand new pulley from Clewett, and it has that stamped steel gold ring there with a bunch of teeth on it. So based on that tooth count and the blank space on the tooth count, the computer knows exactly where the engine is. In addition to the cam sensor, there's right next to it is the cylinder head temperature. That tells you how warm the engine is. There's also an oil temperature sender, which goes right here. This is in the factory oil pressure switch location. It measures pressure and temperature of the oil. This is the idle control valve that I talked about earlier, which is really just a controlled vacuum leak. It takes filtered air here from inside the air cleaner assembly. It goes through here electronically. It's opened or closed to get more or less airflow, and it enters in through this manifold here. So all 6 throttle bodies are going to get the same amount of airflow. All these hoses are equal length. This sensor here is a fuel pressure sensor, and it's mounted to the fuel pressure regulator. This is temporarily located here for the test stand. These hoses are extra long, and this will get relocated to the engine bay, kind of behind that rear window. So this area will get cleaned up quite a bit. This is more in case of a low pressure situation or a bad fuel filter. Something that affects the fuel ratio could be the fuel pressure. So it's good to have that information for the ECU to ponder. And the last 2 sensors are here. This is the oxygen sensor. This is a wideband O2 sensor. There's one on each bank. So I had to weld a new bung there to get a O2 reading on 456. This sensor is the stock sensor. This is what is connected to the oil pressure gauge in the car. And I think this is a different oil temperature sender. So this wire harness is the original wire harness. It goes out to that 14-pin connector attached there to the side of the engine. Okay, so we've talked about the ITB hardware and the PMO piece of it. We've talked about all the sensors and some of the other things. I think the most critical thing on this project is the wiring, and that's why I'm here at Technica Racewire with Philip, who is an expert in wiring. So just give us a little bit about what you do here, Philip.
Yeah, so here at Technica Racewire, we focus on wiring harnesses and wiring harness design and fabrication for Porsche vehicles, specifically for air-cooled 911s. And if people ever want to do EFI conversion, core on plug, using a standalone ECU, that's what we specialize in. And yeah, we're always in between the engine builder and the tuner.
You can do it yourself, but there's certain pins that need resistors.
Yep.
There's things like my build has dual oxygen sensors, and so there's things like CAN bus. If you don't get the wiring right with the shielding right, you get noisy signals. Either the engine's not going to start, or it's not going to be running 10 years down the road.
Yeah, like the focus is having an upgraded system more of a turnkey focus build, where like rather than carbs, it takes a bit of extra work just to get the car running. But with everything modernized, it becomes more reliable. The engine bay is much more cleaner, and with all like the upgraded like wiring, you get more data when you start tuning.
And they provide, in addition to the harness, which we'll show you guys, they provide a extensive document that not only provides all the history or all the sensors and all the components, but it also provides like things like pinouts.
Yep.
Anytime, like say you're at the dyno and something's not working and the tuner, didn't design the harness, they can refer to these documents and they can just say, hey, here's the sensor's not working, which pins are it on, how can I troubleshoot it? That's what they provide. So it makes, I think overall, it makes the project less expensive because when you're paying for dyno time and something's not working, you have the documents to go back and trace it, be able to make changes in the software. So that I think is one of the big benefits to using Technica Racewire.
Yeah.
So thank you for that.
Of course. Yeah.
Everything is clearly labeled with weatherproof plugs.
So this introduction was what I think is the proper way to do EFI. I'm sure you could get by with potentially less if you don't want to do coil on plug, or if you don't think you need the knock sensors. You could probably get by without the idle control valve. But in my opinion, to do EFI right and have it run like a modern car, this is what you need to do. This is going to be the first of many videos on what it takes to really fully implement the PMO ITB systems on a complete running car. Ultimately, we'll end up with dyno time, but check back. I'm going to do more videos on some of the more intensive sensor issues, like with the knock sensor and the cam sensor, some of the modifications needed for the crank sensor and so forth. But we'll do first start video. We're going to do a video on how to calibrate and get all the sensors communicating correctly with the Emtron software. We'll do the harness installation into the car. We'll do driving videos, and ultimately we'll end up on a dyno and see what this guy can really do. So I'm excited about it. Thank you to PMO for collaborating with me on this project. I think it's going to be awesome. You guys know this car is continually evolving. If it wasn't a couple years ago, this car had a 912 engine in it, and now we're going up to this, and we still haven't changed the cams and changed pistons and all that good stuff. So thanks again for being here, guys. I really appreciate you, and this is going to be a fun project, hopefully for both of us. Cheers.